Greetings class, I hope I find you well. In today's lesson we are going to focus on question number 12, extracted from ZIMSEC June 2015 paper 1. We are going to start with the first part of the question, which is part A. It reads, sketch the graph of y is equals to minus ln x. Right, so whenever you sketch the graph of logs or the graph of ln, you first of all identify what you call an asymptote. Let's say you are asked to plot the graph of y is equals to ln x minus 2, something like this, right? You find what you call an asymptote. An asymptote is a boundary line which the curve is not allowed to touch or to have contact with. You need to acknowledge that there is no ln or log of a negative number. There is no ln or log of 0. I hope you are following. So the number here in front of the ln must always be greater than 0 for the graph to be valid. So you need to understand that x minus 2, which is the term in front of the ln, must be greater than 0 for the graph to be valid. I hope you are following. So if I move 2 to the right, you get x is greater than 2. It simply means x is equals to 2 is your asymptote line. So if I draw y-axis here and x-axis here, it means x here is equals to 2. I'm going to put some dotted lines here to acknowledge that when drawing our curve is not allowed whatsoever to touch that boundary line as it represents the asymptote. I hope you are following. Then afterwards, you prepare what you call a table of values, which helps you to find the intercepts where the graph is intersecting the axis. So you want to find the value y when x is 0. So if you put 0 on x here, you are going to get minus 2, and there is no ln of a negative number. So it means this is an asymptote line like what we have highlighted. Then when y is 0, you are going to put 0 here. You get 0 is equals to ln x minus 2, something like this. Then you introduce exponential both sides. So from the previous lesson that we did yesterday, I highlighted that if exponential is raised by a ln power, like ln 9, your answer is the number in front of the ln. Like e to the power of ln 20, your answer is 20. So if an exponential is raised by a ln, your answer is the number in front of the ln. I hope you are listening, class. So after introducing exponential both sides, e to the power of 0 from the laws of indices, any number raised to the power of 0 is 1. So e to the power of 0, you get 1. Then e to the power of ln x minus 2, it gives you x minus 2, which is the term in front of the ln. Since e ln 9 is 9, e ln 20 is 20. I hope you are following, class. So now moving minus 2 to the left, you get 1 plus 2 is equals to x. 3 is equals to x. So it simply means when y is 0, x is 3. I hope you are following. So the point here is 3, 0. 3 for x and 0 for y. This is the position of 3. So I'm now drawing my graph. And this part of the graph must not touch the asymptote line. It approaches, but it is not allowed to touch. So this is the graph. This is how it comes out. Right. So the upper part of the graph is above the x-axis, and the lower part of the graph is below the x-axis. Why? Because when x approaches infinity, ln x minus 2 also approaches infinity, which is positive infinity. I hope you are following, class. So it means this x value, if we increase x value, we continue to have something which represents a positive value of y. I hope you are following. That's why this upper graph is above the x-axis and this lower part is below the x-axis. Right, but however, if you are asked to sketch the graph of y is equals to minus ln x minus 2, right, a negative sign before ln or a negative sign before f of x, it denotes reflection from the transformations. It denotes reflection where x-axis is the mirror line. What I'm trying to say is, we all know that the graph of y is equals to x squared, it comes out with this shape. So if you are asked to draw the graph of y is equals to minus x squared, you simply draw y is equals to x squared first. After drawing it, you reflect this graph with the mirror line, which is x-axis. You will realize that the graph will now face downwards. I hope you are following. So same applies. If I'm asked to sketch the graph of y is equals to minus ln x minus 2, you can start by sketching ln x minus 2, the positive. It comes out like this. Then after sketching it, you reflect this graph by x-axis mirror line. So this upper part is reflected, it comes out below, and this lower part, if it is reflected, it comes out above. So it means this graph now represents y is equals to minus ln x minus 2. I hope you are following. Right, so now that you have the idea and the clue, let us go back to our question. The question is requiring you to sketch the graph of y is equals to minus ln x. So I'm going to sketch y is equals to ln x first. Right. Let me draw the Cartesian plane. This is y and this is x. I hope you are following. Right. So what is the first stage? What is the first step when drawing the graph of ln? The first step is to identify the asymptote by acknowledging that the term in front of this ln must be greater than 0. So you say x is greater than 0. It means our asymptote line is x is equals to 0. I hope you are following, class. Like what we did here, the asymptote, we said x minus 2 must be greater than 0. But if we move minus 2 to 0, you get x is greater than 2. Our asymptote was x is equals to 2. So for this one, you just say x is greater than 0. There is no number to move to the right side. Hence, your asymptote is x is equals to 0. X is equals to 0 is another name for y-axis. So it means when plotting our graph is not allowed to cut, to touch, or to have any contact whatsoever with this y-axis. It is a bounded line which must not be touched by our curve. We refer to this as asymptote. I hope you are following, class. Right. After drawing the asymptote, which is already there, our y-axis, we then need to find what we call the intercepts, where the graph is going to cut the axis. So the intercepts are derived from the table of values, of which this one, we are going to leave it, since when x is 0, there is no value of y which is going to come out as y-axis, or when x is equal to 0 is an asymptote. Right. So we now want to find the intercept, the x-intercept, where the graph is going to cut the x-axis. This is going to be achieved by placing 0 on y. So you get 0 is equals to ln x. If you place 0 on y, you get 0 is equals to ln x. Then you put exponential both sides. So e to the power of 0 is 1. Then e to the power of ln x is x. You now know that e to the power of ln 9 is equals to 9. So e to the power of ln x is x. So x is equals to 1 when y is equals to 0. I hope you are listening. So our graph is passing through 1, 0. This is our origin, and this is 1, 0, where the graph is passing through. So when drawing, you approach the y-axis, but you don't touch. So you need to draw in such a way that the examiner clearly see that your graph is not going to touch the y-axis, but it is going to approach the y-axis. Right. So my graph is heading above the x-axis. Why? Because when x approaches infinity, or when x becomes too large, ln x also approaches in the positive infinity. So the graph is above the x-axis, right? But the examiner is requiring you to plot the graph of minus ln x. So minus ln x is a reflection of ln x, where x-axis is your mirror line. I hope you are following. So if we are to reflect this ln x with this mirror line x-axis, the upper part will come out below, and this lower part will come out above, approaching the y-axis. So this graph here, which is starting from above, moving below the x-axis, is y is equals to minus ln x. This is your graph which is being required. So you now put it on your final sketch. You put it on your final sketch. So your graph is going to come out like this, passing through 1. This is 0, and this is x-axis. So your graph is y is equals to minus ln x. This is how it comes out. I hope you are listening, class. So I want you to stay tuned as we move on to the next question. Right, we are now on part B. It reads, use the trapezium rule with the 3 ordinates. Right. So what are ordinates? Let's say you have your curve here. You have your curve. Right. This is x1, x2, x3, and this is x4. x1, x2, x3, and x4, we refer to them as x ordinates. And if you have y-axis, x1 produces y1, x2 produces y2, x3 produces y3, and so on and so on. So y1, y2, y3, y4, they represent y ordinates. x1, x2, x3, x4, they represent x ordinates. Right, so there is a relationship between what we call stripes. Stripes are also known as intervals. Number of stripes or number of intervals is equals to number of ordinates minus 1. So number of ordinates minus 1, they give you what you call number of stripes, or what you call number of intervals. Right. So what are intervals? From x1 to x2, you get your first interval. From x2 to x3, you get your second interval. From x3 to x4, you get your third interval. So these rectangular, or the trapezium, or the trapezia, right? We have 3 trapezia. They represent what we call stripes or intervals. You can clearly note that if you have 1, 2, 3, 4 ordinates, the intervals are 3, the stripes are 3. So the relationship between stripes and ordinates is number of stripes, which are also known as intervals, right, is equals to number of ordinates minus 1. So when attacking trapezium rule, the formula is area is equals to h over 2, you put open bracket, Then you write y1, which is the first y ordinate, plus y last, which is the last y ordinate, plus twice the rest ordinates of y, something like this, right? So how do you then find h? To find h, you say upper limit minus lower limit divided by number of stripes. Upper limit minus lower limit divided by number of stripes. So from our question, we want to calculate trapezium, using trapezium rule, the area bounded by the curve y is equals to minus ln x. So you put minus ln x in integral, something like this. From x is equals to 2 to x is equals to 3. 2 is your lower limit, 3 is your upper limit. So I'm going to say 3 minus 2. Then you are going to divide by the number of stripes. So the question gave us ordinates, not stripes. But if you less ordinates with 1, you get what you call stripes. So if you have 3 ordinates, you are saying 3 ordinates minus 1 is equals to 2 stripes. So I'm going to divide this by 2. 3 minus 2, you get 1 over 2, which is equals to 0.5, representing your height. I hope you are following. Right, then I'm going to prepare a table for ordinates. On my left side, you have x ordinates. On my right side, you have y ordinates. So you have x1, which is the first x ordinate. This first x ordinate is equivalent to the lower limit, and our lower limit is 2. Then the second ordinate, which is x2, is found by adding the height. So the height, like from here to here, you got 0.5. From there, x2 to touch x3, you simply add 0.5. So 0.5 is acting as a common difference between the x1 and the x2, the x2 and the x3. So to find x2, you simply add 0.5 on 2, you get 2.5. Then to find x3, you add 0.5 on 2.5, you get 3. So the last ordinate, which is 3, must be similar to the upper limit. I hope you are following. Right, so x1 is going to give you y1. y1 is going to be obtained by substituting x1 into our curve y is equals to minus ln x here. So you are going to put 2 on x. So y1 is equals to minus ln 2. I hope you are following. Then y2 is equals to minus ln 2.5. Putting 2.5 on x, you get minus ln 2.5. Then y3 is equals to minus ln 3, something like this. Right, so after that, you then apply or you then substitute your values into the area of trapezium. H over 2, open bracket, y1 plus y last plus twice the rest. So I'm going to start by substituting the height. Remember, the height here is half, where half is good is 0.5. So you put half here as your height divided by 2. So my height is half divided by 2. It is going to give you 1/4. Since 2 is going to multiply the 2 below, then you put your big bracket. y1 is the first y ordinate produced by x1, and this is minus ln 2. This is our y1 minus ln 2. Right, then we are going to add it with y last. Y last is minus ln 3. So plus minus ln 3, you get minus ln 3. Since plus times minus, you get minus. Then you write plus 2, open bracket. By rest, I refer to the remaining ordinates. After taking the first and the last, the remaining ordinates between y1 and y last are now added inside the bracket. So we are left with minus ln 2,5. You put it in the rest, then you close. So we are going to punch this in our calculator. What you get? You get negative 0,906085, something like this. So the reason why our answer is coming out as negative, it is because our sketch of the graph, we obtain something which is below the x-axis, so you get a negative result. But when presenting your answer, you put this in modulus so that you take the positive part, since area cannot be negative. So your final answer is 0,906085, ignoring the modulus. Right, so according to the question, what is the instruction? The instruction is saying give your answer correct to 4 decimal places. So I'm going to count 4 decimal places. 1, 2, 3, 4. So my final answer is 0,9061. This is the final result. I hope you are listening, class. I want you to stay tuned as we move on to part C of the question. Right, so part C of the question is requiring you to evaluate integral of minus ln x, where 2 is the lower limit and 3 is the upper limit. So there is no direct integral of ln x, right? For you to integrate ln x, like for questions like integral of ln x minus 2 dx, integral of ln x, integral of ln 3x plus 2 dx, something like this, there is no direct integral of ln as with derivative. Remember, for differentiation, if you have 4x minus 1 and you want to find dy dx, you first of all find the derivative of 4x is 4, the derivative of minus 1 is 0. So you divide derivative of 4x minus 1, which is 4, by 4x minus 1, and this is your answer. This is how you find the derivative of ln. It's derivative of 4x minus 1, which is 4, divided by 4x minus 1. But when it comes to integration, there is no direct integral of ln x minus 2, ln x, and ln 3x plus 2. You have to apply integration by parts. Whenever you approach integral of ln, it is integrated using integration by parts. So what you need to do is you put a silent 1, you write minus as minus 1, so that minus 1 represents a function and ln x represents another function. You now have the algebraic function, which is minus 1, and ln x, which is the ln function. So you have 2 functions. And for integration by parts, you must have u and v. You must have 2 different functions, actually. I hope you are following. Right. So, what is u? What is v? You are assisted by the troubleshooter, which I normally refer to as let. Let is more of a BODMAS, which helps you to identify u between the 2 functions. L stands for ln x, A stands for algebraic expressions, T stands for trig ratios, E stands for exponential. So the first letter from the above is your u. So minus 1 is representing algebraic expressions. Ln x is representing L. From the let, L is on top of A. It simply means u is going to be represented by ln x, since ln is the one which is starting followed by L. I hope you are listening. So of the two functions that you have, the one that you are going to name U is the one above, or it is the one which starts at the top. So our U is going to be represented by ln x. You find du dx. So derivative of x is 1. Then you divide it by x. We have explained it earlier. So du dx is equals to 1 over x. Right. Then what is v? V is the integral of the remaining function. The remaining function is minus 1. So if we integrate minus 1, the output after integrating minus 1 is your v. I hope you are following. So integral of minus 1 is minus 1x, which is good as minus x. This is going to represent your v. I hope you are following. Then after that, you write the formula. Integration by parts is uv minus integral du dx times v dx. So this is the formula for integration by parts. I hope you are following, class. So I now substitute uv. You are multiplying ln x with minus x. You get minus x. Ln x, something like this. You put your minus. Then du dx is 1 over x. So you are saying 1 over x is your du dx dot product. V is being represented by minus x. You put the x, something like this. So you get minus x ln x minus. Minus and minus, they give you plus. So I'm now writing a plus. Since minus outside the integral and minus inside, they give you a plus. Then x and x, they cancel off each other, leaving you with the 1 inside. You get minus x ln x plus integral of 1 is x. You put x. I hope you are following. But since we have the limits, which are 3 above and 2 below, there is no need for you to say plus a constant term, because the integral has limits. So what you need to do is you say bracket minus bracket. So in the first bracket, you substitute the upper limit 3. In the second bracket, you substitute the lower limit 2 on x. So here you get minus 3 ln 3 plus 3. On this one, you get minus 2 ln 2 plus 2. I hope you are following, class. So collecting like terms, minus 3 ln 3 plus 3, minus times minus, you get plus 2 ln 2, minus and this is plus, you get minus 2. I hope you are following. Right, so this one can be written as minus 3 to the power of 3 plus ln 2 to the power of 2 after moving this 2 on top of 2 using power rule. Then 3 minus 2, you get plus 1. Right, so this is now ln 4 minus ln 27 plus 1, which gives you ln 4 is ln 2 squared, ln 27 is minus ln 3 cubed. So this is ln 4 over 27 plus 1. Right, so according to the instruction of the question, evaluate integral of minus ln x, correct to 4 decimal places. So this exact value, which is ln 4 over 24 plus 1, we want to put it to 4 decimal places. So we are saying ln 4 divided by 27. Then you add with 1, you get negative 0.90 0.095. But remember, since our area is always positive, you treat it as modulus. It gives you 0.9095 square units. So this is the instruction for decimal places. So I want you to notice that trapezium rule, it gives an estimate, but integration, it gives you the exact area. Why? Because if you have your Cartesian plane, something like this, let's say this is your curve, right? And you want to find the area from 1 up to 2. You draw a line connecting the upper part of 1 and the upper part of 2. So if you calculate using trapezium rule, the answer that you get is this shaded part, which covers from 1 to 2 but below the line. So trapezium tends to ignore this space which is not shaded. It ignores this space. So trapezium, it gives an estimate or an approximate value of area, but not the exact. But if you integrate, integration, it covers everything below the curve, including that space which was left by trapezium. I hope you are following. Right. So whenever this question comes, be ready to be asked what you call relative error or what you call percentage error, which helps us to identify the percentage difference between the estimate value and the exact value. I want you to stay tuned as we move on to part C2 of the question. Right, we are now on part C2 of the question, which is part C2.1. Hence, calculate the percentage error using trapezium rule to estimate the area. Right, so remember, percentage error, another name for percentage error is relative error. Right, so to find the percentage error, or what you call the relative error, we use the formula exact value minus estimate over exact times 100. Exact value is the answer that was derived through integration. Estimate value is the answer that was derived through trapezium rule. I hope you are following. So from our workings, our exact value was expressed to 4 decimal place, which is 0.9095. So I'm going to write 0.9095 on exact. Then the estimate is the answer derived from the trapezium rule. So from the trapezium rule, what you got? 0.9061. So I'm going to put 0.9061. Then you divide by the exact, which is 0.9095, so that you multiply by 100. So if you find this in your calculator, 0.9095 minus 0.9061 divided by 0.9095 times 100. What do you get? 0.37. Give your answer to what? Never mentioned, so we can give it to 3 decimal to 3 significant figures. So your answer is 0.374%. So this is your percentage error or your relative error. I hope you are listening, class. Right, let us move on to the last part of the question. It reads, explain why the trapezium rule gives an underestimate of the area. Right, so to explain, you can make use of your graph to explain. Right, remember we started from 2.5 and up to 3. These were the x1, x2 and x3 ordinates. So if we are to draw our trapezium, you can notice that if we connect this and this, there is a space here which is being left out, the one that I have shaded. So you can start by drawing a sketch, then you explain to the examiner that trapezium rule is not included the shaded area. Trapezium rule has not included the shaded area. Therefore, it underestimated the area. By leaving this space, it underestimated the area. So you simply say trapezium rule has not included the shaded area. So you can attach your statement with this simple sketch so that the examiner clearly see your argument. You are saying trapezium is including the unshaded part, but it is excluding this shaded part, which is part of the exact area. So trapezium rule has not included the shaded area. That's why it is estimated the area. I hope you enjoyed today's lesson. Till we meet again, shalom.